In this video, we're going to talk about data and how it's represented in the C language. Now, whenever we write a computer program, no matter what language, our job is to transform and manipulate data. So we have data that comes into the program. The program's job is to figure out how to change that data, create new data, do whatever it is the program is supposed to do, and then output that data somehow. And in the meantime, we might generate some temporary data that we need in order to carry out this transformation. So we know from earlier classes that there are many different types of data, different kinds of data that we want to manipulate and transform in our programs. There might be integer values, real numbers, fractions, video, sound, text, and all sorts of different things. And today we're going to talk about three specific types of data that are directly supported by the C language. Now, formally, from a computer science definition standpoint, a data type is something that specifies a set of values, like the set of all integers, for example, or a range of integers, and then the operations that may be performed on those values. Those things constitute a data type. Today we're going to be talking about the values and how you represent them in a C program. The first type of data we'll talk about are integers. So integers are familiar to you from ECE 109. We know that inside a machine, a computer, we generally represent an integer value as a 2's complement binary value. And there are a certain number of bits, n bits, in our 2's complement representation, and that restricts the range of integers that we can represent with this n-bit number. In C, there's no specific standard size of an integer, and it depends on the platform you're running on. And in C, we don't write our numbers in binary. We write them in decimal, base 10, or hexadecimal, base 16. So decimal numbers are written the way you would expect. 1, 2, 3 is the representation of 123, so the ones digit, tens digit, hundreds digit, and same way we've been writing all through elementary school and on until now. Minus 76, 2048. There's no comma here in the larger number. We just write all the decimals together. And there's no spaces, of course, in between. That would be two separate numbers. For hexadecimal numbers, base 16, we preface them with 0x. Okay? In LC3, we just use the x, but in C, the prefix of a hexadecimal number is 0x. And that's very important. X can be uppercase or lowercase. The letters in the number, the digits can be uppercase or lowercase. That doesn't matter. So this is a hexadecimal number, 7b, which happens to be the same value as decimal 123. Here's a larger hexadecimal number. We can think of this as a very large unsigned value, or if we know that our underlying machine has 32 bits, then this is the same representation that we would see for the decimal number minus 76. And then here's the 0x800 is the same as 2048. So we have to write our integers either in decimal or hexadecimal. There's no standard binary notation for writing a binary number, so we have to write integers this way. Now for real numbers, we can't really represent the whole set of real numbers because that's an infinite number. But we can represent numbers that are very large, much larger than an integer can be, and have fractional parts. And we use floating point representation to do that. And you remember from ECE 109 that we have a machine representation for floating point. It usually has a sign bit, some number of bits for an exponent, and then some number of bits for a mantissa. This is the IEEE floating point standard is one example. In C, we don't worry about that, how it's represented underneath. We just write it with a decimal point. Any number that has a decimal point in it, whether or not it has anything to the right of the decimal point, is considered a floating point number. 6.0 is the number 6, but we're telling the program to represent this number as a floating point value rather than as an integer value. Minus 12.37962, there's no limit to the number of decimal digits we can have to the right. If we have something that's very large or very small and we don't want to write a bunch of zeros, then we can use exponential notation. So this e means 10 to the something, So this is 6.07, E23 means 6.07 times 10 to the 23. So the E is followed by an exponent, that's an integer value, it can be positive or negative. So here's an example, 23e to the minus 7 is the same as 23.0, we don't have a decimal in this case, times 10 to the minus 7. That's how we write floating point. We must use decimal notation to write floating point numbers in C. The third kind of data that's directly supporting the language is text. When we think about text, we can think about a single character of text, or we can think about a string, which is a sequence of characters. And we represent characters using the ASCII table that we talked about in ECE 109. And in C, when we want to write a single character, we use a single quote around it. So this is the character, capital A. This is the character, lowercase x. This is the character, ampersand. Anything in the ASCII table can be represented this way. Some things don't have nice printable representation, so we use this special backslash to represent, in this case, the new line character. There are 10 or 12 of these different codes that you can look up and use for special characters, but we'll see /n a lot as the new line character. Again, because it has a single quote, even though there's, we write two things in here, this represents one character, the new line character. Now if we want a string, we have to use double quotes. So when we use double quotes, we can put any number of characters in between them, and that's a sequence of characters that represents a single string. We can have spaces, we can have punctuation, we can have line feeds, whatever we want inside that string. So I told you that C represents these three data types in the language. They're called native data types because they're part of the fundamental language. And the names of these types are shown here. So car is used to represent a data that is a single character. Int is used for data that is integer. Float or double are used for floating point. And as we go up this list, we increase the size of the representation, and therefore the larger number of values that we can represent with each one. So in other words, float and double. Double is larger than float, so we can represent a larger range of values with a double than we can with a float. I'll tend to use double as our floating point type in our programs because that's what the Patton Patel book uses. But in any case, you can use float or double. And notice there's no string. There's no type here for string. C does not natively support a string data type. So to manipulate strings, we have to deal with a sequence of car values. And we're not ready to talk about that yet, but we'll use literal strings from time to time, and then later we'll figure out how to represent a sequence of values of type car to get a string.